Hey everyone, welcome to the next installment of Getting to Know the Speaker. I'm excited today to introduce you to a friend of mine, a colleague, someone who I think has got some really good content for us coming up, Reis of Ternary Data. Hey Joe.
How's it going?
Good, good. Thanks for joining us today. Well, as many of you may know, having watched our series so far, we want to talk to Joe about his background, what he's been doing, what his company's doing, and then give you a little taste of what he's going to be talking about at Flow Factor. So why don't we just jump in? Joe, why don't you tell us a little bit about yourself, a little bit about your journey from when you started your career sort of to where you are today?
Yeah. So I've been involved in the data space for a long time. My background's in mathematics, and started out in analytics, I guess whatever you would call data science these days. I was probably doing it back in the 2000s. And then as big data started becoming more and more of a thing, say like the 2010s, early 2010s, late 2000s, I started getting more of an interest in machine learning, because we actually had the computation now to start doing solving these types of problems. So gravitated towards the ML space and started realizing like a lot of the problems were not necessarily machine learning or analytics problems. They centered around data engineering. The tooling at the time was extremely immature in terms of getting the data into a place where it was useful for machine learning. So at that point, I kind of gravitated more towards data engineering actually, as opposed to sticking with ML or I guess whatever data science is these days. So yeah, that's been sort of the progression. And then met my partner with Ternary Data, Matt Housley, and realized that we had a pretty similar story where every single time we've seen companies want to do data science, they inevitably become data engineering problems. And so we jokingly refer to ourselves as recovering data scientists as a result. And so and instead of focusing at the top of, if you picture like the hierarchy of needs of data and AI sitting at the top, that's great, except you also need the foundation. And since we've, historically been hired to focus at the top without, setting a good foundation, we decided why not just start a company around building a foundation for companies to help them succeed with data science. So just a little bit about the progression and how we got to where I am today. So
okay, awesome. So before we move on, I wanted to ask a couple questions. So we've done a couple of talks so far in the series with folks in the data science, machine learning, data engineering track. And one of the things that I've wanted to ask and I haven't is, do I need to have a PhD in math? Because I think all you guys have a PhD in math or very close to that. If I wanted to get involved in machine learning or artificial intelligence, do I need that kind of a math background?
No, I don't think so. I don't have a PhD in math. So I think that it's a bit of a misnomer. I think if you're doing like intensive AI research, it would certainly help to have, I think, PhD level skills. But I think more importantly, it's having like a passion for learning. I think a really good idea of the domain that you're trying to solve within, and then also I think just the ability to continue learning new stuff, right? But at the same time, you're talking about a space where the tooling is becoming more and more, I guess, democratized, for lack of a better word. So even a layperson, I think, could effectively do pretty sophisticated things with machine learning, whereas even a few years ago that wasn't possible. You're starting to see the notion of a citizen data scientist becoming, I think, more prevalent in the fold. So I'd say the requirement of being a PhD it might be a nice to have and a cherry on top, but I don't think it's necessary to be effective with data.
Okay, awesome. You also mentioned data engineering, and that's something we've touched on a little bit with some of the other interviews as well. But tell us a little bit about when you say data engineering, what you mean by that. And you talked about, sort of getting data ready to be used at the top of the pyramid, but you got to get the bottom, correct. But what does that mean to you, and how can companies start addressing that issue now and getting ready for AI and ML?
Yeah, I think, I mean, data engineering, I think, is becoming a fairly overloaded term, just like data science has been. But maybe the distinction really is that you're providing, the infrastructure for to enable data science or to enable more advanced data analytics. So that can be everything from, I would say, historically that's been the realm of what they historically are called ETL developers, maybe some DBAs or whatever, where you're setting up data structures, data infrastructure, to house data, to move data, to transform data, and so forth. That hasn't gone away. I would say that is classically data engineering even today, right? And now the ability to deal with both batch and real-time data. And now, I would even extend that to, there's a couple new areas where I would say software engineers are becoming data engineers. There's the notion that applications really are data products at the end of the day, right? So software engineers continue that last mile step to embed, intelligence into applications. There's also the flip side of it, which are machine learning engineers, right? So, these are engineers who sort of exist in this duality of understanding machine learning and also understand, I guess, whatever data engineering, however you define it, but able to meld these two together. So, they'd be able to take data, make it useful for a machine learning algorithm, and then, be able to take those models produced, from machine learning AI and deploy those to production for use. The downstream uses of which would be, incorporating them into an application or an API or something like that. So it kind of runs a whole gamut these days, honestly.
Okay. So with that in mind, if I was at a company and I could see where machine learning might be valuable for our domain, what might be my first couple of steps? Let's pretend I'm a CTO and I've been reading about this and I know, okay, this is definitely something we could leverage in our organization. What might be the first couple of steps that we take to get started down that path?
Anymore, I'm trying to step back and answer, I try and figure this out from a non-technical lens first. So the question I would really ask is or is the problem that we're trying to solve, is that core to the business, right? And then if it is, do we have the team to execute on solving this problem by using these new techniques, whatever they are, right, or new technologies? So I think I always approach things from a problem first, team first perspective. Because if you can solve a problem that's useful to your business, that's great. You should always be doing that, right? Maybe I'll get into an anti-pattern in a second to sort of, I think, contrast that. But secondly, if you don't have the team, then what do you have, right? So, and on the team notion too, I would say that sort of a tangent, sort of not, but what we see a lot of is what we call resume-driven development. So, and that tends to be where you'll get a team of people who want to do data science because that's all the rage these days. Everyone wants to do data, but you got to make sure that they're solving a problem and they're using technologies that are actually going to further the aims of the company and not just somebody's resume. So
yeah,
those are the things I'd be looking out for as as an executive. Again, our company, we're brought in in a lot of cases to help advise companies on how to pursue a path in AI, or whether that's even something that they should be thinking about. Because there's a whole list of steps you got to think about before you even get there, right?
Yeah.
The whole pyramid. So
yeah.
it starts with people. So.
And I'll get when we're done, get a link from you for that data hierarchy of needs pyramid, and we'll include that in the show notes. So you started off with, what problem do you have? How does that relate to your business? What, just for some of us like myself that don't do a lot in this space, what would be a couple of types of problems that either, maybe we start with machine learning. What kind of problems would be the right, if you can say that, problem for a machine learning solution? What have you seen in your travels?
So, businesses really need to answer certain questions, right? Like, how many things am I going to sell today and tomorrow and next year and so forth, right? Like that's classically been a forecasting type of problem. So that's not even machine learning per se. You can use, I think, classical statistical methods for that. So that's one thing. I would say, if you step back even from like using machine learning to just using like good data practices and good data hygiene, like those are types of problems that I'd be looking at solving. Like how much is like lifetime value? How much is the customer worth to me, right? So I can figure out how much it costs to acquire a customer and keep a customer and so forth. Customer churn, how often are customers leaving me? So I know how many customers I need to to fill in for that population. So I would say just like really commonsensical, business oriented problems like that, that I would say you could do these in Excel, honestly. I mean, I used to do these in Excel. So uh,
Okay.
they're not hard, but I think some people may overcomplicate them, right? Especially nowadays when everyone wants to, like I say, do machine learning and data. But, machine learning, I would say would be useful for like problems where you either need to like forecast a number, or you want to classify things into groups, like yes or no, or yes, no, maybe, or red, blue, green, or whatever. Or if you want to like cluster your data together in ways that you couldn't accomplish with like a group by statement in SQL, for example. So,
Oh,
but that would depend on the domain problem too, right? Because every company has its domain it operates in, and every problem is different. But I would say it's a good framework to understand, like, do you need to if you're given data and you want to like see patterns in data, um, are you looking for like a numerical type of answer, or are you looking for like a way to classify answers on unseen data, right? So
okay. Awesome. Yeah, I think in my travels, specifically having been in retail for a long time or e-commerce, uh, when I think back to the first time I saw maybe some machine learning stuff, actually, I guess it wasn't even in where I was, but it was more like the Netflix, recommend movies, right? So, or maybe even something earlier than that. Actually, now that I think about it, is the Music Genome Project, right, at Pandora. That ability to break all the pieces out of a piece of music and then find everything that's sort of like that. And yeah, does that kind of line up with what you might see as a machine?
right, these are very like domain specific problems, but the way you solve them is, I would say, it's going to be unique to your problem. Honestly, like Pandora had a very specific use case, right?
Yeah,
Netflix, right? Like you can apply like classical like recommendation systems to these types of problems, but they're always going to be, it's always a kind of like the last mile or the last 10% or 5%, whatever that you need to accomplish. So that's where it gets pretty cool for companies,
yeah,
and that, I guess you need to dig a bit deeper and go that extra thing, because like Netflix, like I said, they could apply just a traditional like recommendation engine that wouldn't have solved their particular problem that well. So yeah,
okay,
I think it's a combination of, I think, understanding like what's available out there in the universe of ways to solve these problems, and then obviously you got to have super good domain expertise to understand where the limits of those solutions will take you. So the more you need to start getting creative and really trying to solve your own problems. So
okay, awesome. Well, I think that actually might be a good tie-in to talking about your presentation at Flow Factor Conference. So Joe will be doing a session in the morning on June 11th called Unified Data, Unifying EDW and Big Data in the Cloud. So why don't you tell us a little bit about that, Joe, what people might expect for you to talk to them about?
I think that the thesis really is that it's part the issue that data silos are a real thing, and they're really dangerous for companies. And so it's about the notion of unifying data, as the title says. But what does that mean, right? What it means right now, especially in today's world, is that there's a paradigm going on where you have the ability to analyze data in batch, i.e., you get data, look at history, and it may not be data that is recent, but you can do stuff with that data. But coupling that with data that is coming in real time, and being able to respond to these types of real time events in a unified way, right? So that, I guess, is roughly the notion of what this talk will be about. So
Okay, I'm glad I asked because I hadn't thought about that real time mixed in with batch to kind of help give you a better insight, I guess, right? So that you're not just looking at historical.
yeah, exactly. I mean, yeah, it's It's something that we're seeing quite a bit of right now. But even if you take the batch perspective and just look at that, like unifying even your batch data is, I think, a really important thing as well. It's shocking how many companies have batch data silos really when they don't need to be there. You have one data set over here, one data set over here, and who's deriving value from that, right? Because with silos also comes, the notion of like flow factor really is about like undifferentiated heavy lifting as well, right? So these are all undifferentiated practices within a business where you possibly have redundant data or data that reinforces an organizational silo, right? And in today's world, it's I would say you do that at your own risk. You can continue having silos and enforcing these systems that I guess perpetuate silos, but that's I would say it's pretty dangerous these days. You get into why certainly, but yeah.
It's interesting when you said that. It reminded me on the microservices architecture, we talk a lot about Conway's Law, and as a short definition of that, organization's communication structure is reflected in its system design. And based on that, as you were describing that, I was thinking, I think Conway's Law applies here, right? The org's communication structures also are represented in their data silos, really. Yeah. And of course, the downside of that is if a company has poor communication, you probably have poor APIs and poor, microservice communication. And it sounds like that's probably true as well on the data side, that you've got these silos and people really aren't, since they're not actually talking, they're also not, leveraging each other's data.
Conway's Law is a really big thing that we hit on quite a bit. Conway's Law, I would say, is that's actually a lens through which we view a lot of companies when we engage with them, for example, right? Like the first thing I start looking for are like very subtle cues, like how, are departments talking to each other? Do people in different departments know each other, right? Very non-technical things, because from that you can start reading in, okay, so if the people don't know each other, I'm almost willing to bet you $100 that their data systems and the way they communicate and the way they use data is also going to be siloed. Conversely, I would call it the first name test. If you can go into a company and talk to people and they can refer to other people in different departments by first name, then that tends to definitely, I think, indicate that these companies can work with data in a way that is productive. So yeah, Conway's Law, I think your observation with microservices is absolutely spot on. Like we use that all the time as one of our litmus tests. So yeah,
awesome.
But it's amazing. Like I would say, how often, because I think when you step back and you look at sort of the evolution of where software engineering is going now, from monolithic to microservices and how to whatever else is going, functions as a service or whatever latest thing. But if you step back, I mean that the notion of that movement along with the DevOps movement has taken software engineering, I think, quite a ways. I would argue that data is actually more backwards than software engineering right now. Mm. Because people take the notion of data for granted. It's like, well, I'm able to make my decisions, therefore, what does it matter if the rest of the organization doesn't? And so you have, I think, a very monolithic way of for an organization to operate. It almost seems the people within it may think they're operating in a microservices architecture because they're just off doing their own thing, but the business can't communicate with itself, therefore it doesn't work. So the API connections, I suppose, if you want to make that analogy with people, like they're broken. So
yeah, for sure. Awesome. Well, thanks so much for taking time today, Joe. I know you're got a lot going on. Excited to see you in a few weeks, although this video may be out closer to that than today. But before we wrap up, one of the things I've been talking with everyone about is a little Easter egg, something to reward the folks who have got this far in the video. And the Easter egg is really a question that you, if somebody in the event were to walk up to you and say, hey, Joe, here's my question, you'd be like, oh, you watched the video, thanks, and let's have a talk. So what would be that Easter egg question that you would want someone to ask you?
Yeah, I would challenge everyone to think about how you want to win with data in the next 5 years, right? And there's a lot to unpack in that question. but feel free to unpack it and let me know your answer. I'm very curious to hear about it. So,
Okay, awesome.
So,
well, thanks very much, and we will see you in a couple weeks.
okay, awesome. Thanks. All right, see you.